Myself Tasnim Makandar from BSc First Sem CBZ combination. My topic is to determine refractive index by using a base refractometer. Introduction. This presentation focuses on the determination of refractive index using an abbes refractometer. We will explore the fundamental principle behind refractometry and provide a detailed understanding of how light interacts with materials. Understanding this concept is crucial for precise material characterization in various scientific and industrial applications. Refractive index. Diffraction is the bending of light when it travels from one medium to another due to a change in its speed. The measure of this bending is known as the refractive index of material. Principle of refractometry. When light enters a denser medium for a rare one, it bends towards the normal. At a particular angle of incidence, known as the critical angle, the refracted ray travels along the boundary between the two media. The refractometer works on this concept of critical angle of measurement. It relates refractive index as n is equal to sin I by sin r. However, the base refractometer is designed such that the refractive index can be directly read from the scale once the light-dark boundary is adjusted correctly. Concept of refractive index. The refractive index is dimensionless number that describes how light propagates through a medium. It is defined as the ratio of speed of light in a vacuum to its speed in the material. This value helps identify material properties and purify by measuring how much light bends or refracts when entering the substance. Measurement of refractive index. Refractive index can be measured by three main instruments, that is abbes refractometer, immersion refractometer, pulfrich refractometer. Refractometer means a instrument that is used to measure refractive index. Abbes refractometer. An abbes refractometer is a benchtop device for the high precision measurement of an index of refraction. Instrument components and setup. The abbes refractometer consists of a prism, a light source, and an eyepiece for observation. Proper setup includes calibrating the instrument with a reference liquid, typically distilled water, to ensure accuracy. Familiarity with its components enables efficient operation and precise measurement outcomes. Construction of abbes refractometer. An abbes refractometer mainly consists of two prisms, that is upper and lower, between which the sample is placed. Telescope or viewing lens to observe the light dark boundary. Light source, usually sodium light. Adjustment knobs to make the boundary sharp and align the crosshair. Scale that displays the refractive index directly. The lower prism is illuminated and the upper prism helps to spread light uniformly through the sample. Procedure. Firstly, clean the both prism. Place 2 to 3 drops of given sample on the lower prism. Close the upper prism firmly, ensuring no air bubble remain. Direct light into the illumination window of the refractometer. Look through the telescope to observe the boundary between light and dark areas. Adjust the dispersion correction knob to sharpen the boundary. Rotate the measuring knob until the boundary coincides with the crosswire. Note the refractive index reading from the scale. Repeat the measurement to obtain the average refractive index reading. Result. The refractive index of the given sample using a base refractometer is found to be n is equal to average value. Applications. Used in food and beverage industry to check purity, example sugar concentration. Quality control in chemical and pharmaceutical industries. Identification of gemstone and optical materials. Used in research laboratory for optical characterization of liquids. Importance in material characterization. The refractive index is a critical parameter in material characterization, providing insight into the composition and purity of substances. It helps identify contaminants, confirms material consistency, and aids in quality control for pharmaceuticals, chemicals, and optical products. Accurate measurement ensure reliable product performance and complies with industry standards. Conclusions. Accurate determination of the refractive index using a base refractometer is essential for material analysis and quality assurance. Mastery of instrument setup, sample preparation, and result interpretation ensure reliable and reproducible measurements, supporting better decision making in scientific and industrial contexts. Thank you.